Prashant sir, good morning.
Good morning, Professor. My voice is audible, Professor?
Yes, sir, is it audible, sir?
Thank you, Professor.
Thank you.
Dear participants, very warm welcome to one and all gathered here. Once again, very warm welcome to all the participants who are all gathered for this day 2 of this ATAL sponsor FDP on blockchain. Now, I would like to call Dr. B. Muthukumar, the coordinator and the head of the Department of Computer Science Engineering, Sedamal Engineering College, to introduce our today resource person. Sir, please, sir.
Yeah, thank you, John. A very warm good morning to one and all gathered here. So, today we have an eminent speaker called Dr. A. Prashant. Dr. A. Prashant, he did his Bachelor of Engineering at Sri Krishna College of Engineering and Technology, Coimbatore. He completed his postgraduate degree in PSNA College of Engineering and Technology, Dindigul. Also, he has completed his doctoral degree from Anna University, Chennai, and currently he is having 8 years of experience in teaching community. So he's a member. He's having a membership in professional bodies like ISRD, and he has published many peer-reviewed journals around 16 plus. He's having more than 5 numbers of publication in SCI journal, and he's having more than 10 international conference he has published. He has delivered so far 20 various speakers in various titles in many of the reputed institutions. He has published nearly 8 books with ISBN. He has published 2 patents. He is a member. He is an editorial and review board member in many reputed peer-reviewed journals, around 14. So far, he presented his project and innovative ideas around 12 numbers. He is well versed in tin eCard software and Cisco packet tracer. His area of specializations are IoT, blockchain, wireless sensor network, wireless communication, artificial intelligence, cyber security, big data, soft computing, and he has received many honors and awards. So with this, I just want to mention some peculiar awards what he received. He received Young Scientist Award from International Scientist Award 2020 on Engineering, Science and Medicine at Visakhapatnam, which is held on November 2020. He received a Researcher of the Year Award 2020 from Second International Business and Academic Excellence Award at Delhi in December 2020. He received Young Researcher Award from Institute of Scholars Award in the year 2020. He received Young Achiever Award from National Academy Excellence Award in the year 2017. He received Best Young Faculty Award from International Engineering Excellence in the year 2015. He also received many scholarships for doing higher educations from social Shanti Social Service Trust, Coimbatore. With this, we have an eminent and interesting resource person today with us. He is going to have a discussion on role of IoT in blockchain in session 1 and research challenges and issues related to blockchain, how it is integrated with IoT in session 2. I hope these 2 sessions will help you in order to understand how the IoT concept will be implemented in blockchain. So with this, I welcome our resource person, Dr. A. Prashant, to deliver the session. Sir, thank you so much. Right.
Thank you,
It's your,
Professor.
thank you, sir. Thank you. Welcome.
Thanks for the brief introduction about me. Thank you, Professor. So shall I start my session?
Yes, sir. You can start, sir.
So my screen is visible.
Yes,
Professor, my
sir.
screen
It
is
is visible.
visible.
Yes, yes, yes. Visible, sir.
It's moving.
Yeah.
Okay, thank you. Thank you. So very good morning to one and all present here. Good morning, participants. So my voice is audible.
Yes, it is audible, sir.
Okay. So first, I would like to thank head of the department, management, even coordinator for giving this wonderful opportunity to deliver the sessions. Moreover, we thank ATAL for providing various FDP programs to develop the innovative skills of faculty members. So particularly this FDP covers one of the emerging technology, blockchain. So I'm very happy to part of this FDP. In particular, this session deals with 2 emerging technology. So that is the beauty of these sessions. So we all know about the 2 sessions separately. So we know already about IoT, and we know already about blockchain, because various legendary professors already thought about what is the blockchains, all of the architecture, all these things are discussed in the previous sessions or maybe upcoming sessions. But today, these 2 sessions so covers 2 areas. So how IoT work, or how blockchains are work, how they integrately work. So that is the additional challenges we are faced in day by day. So my plan is this first sessions covers most of the part related to IoT, because most of the faculty or most of the participants are from various domains. So I just give some intro about IoT and continue with the second session. I just start with some intro about blockchain, and I continue with how we can integrate the IoT and blockchain. So all these things are discussed in the second sessions. So my plan is like that. So these are my some agendas. As I already mentioned, I start with some introduction part. So most of the cases I covered in the first sessions related to IoT, and second session, first 20 to 30 minutes I covered with some blockchain concept, and final 1 hour I related to how we can integrate IoT with blockchain, and what are the integration applications available in the recent years, and what are the challenges available while we integrating blockchain and IoT. So my voice is okay. Shall I continue?
Yes, sir.
Okay, thank you. So first we start with one of the emerging technology, thirst area. So in the last few years, most of the researchers done their research related to IoT. So I start with some intro about Internet of Things. So as we all know, the term internet provides a connection between computers. Next term, things. Things, sometimes called as object, sometimes called as devices. For example, computer. You can take computer, desktop, mobile, even car is an object. So now we can frame the definition of IoT with help of these 2 terms. So IoT is nothing but n number of physical devices connected over the internet for sharing of data. So with help of IoT, we can share our data in a very secure manner. Internet of people and things. So you can take in past 10 years, in 2010, the people connected to internet, the connected devices are 12.5 billion. But now, in 2020, the people connected to internet, things connected to internet, and in addition to that, things connected to things. So here, the connected things are 212 billion. So there will be a huge difference in the last 10 years. So from this, we can evident that IoT play a significant role in the technology upgradation. So definitely IoT will rule our world maybe in upcoming 5 years. But still, some challenges, some drawbacks in IoT. So that will be overcome with help of our blockchain. So that is the additional part of our IoT. So how the IoTs are formed? So you can take in 1960s, there will be a communications or exit between two hosts. Host means you can take two computers. After that, the same communications are exit, but one computer in one place, another computer in some other location. So that communication will be achieved with help of term internet. So the internet era is arisen in 1990s. After that, the internet will be provided through mobile phones. The same way, the people also connected to the mobile phones, and finally, in 2015, the communications are exit between every object. As already mentioned, object means sometimes called as a device, sometimes called as a things. So the communications are exit between every things. That can be achieved with help of our IoT. So from the participant side, anyone can answer for this question. Is it possible to assign addresses to all the devices in the world? Is it possible to assign addresses to all the devices in the world? Yes or no?
Yes, maybe.
Yes.
Yes.
Yes. Thank you, Professor. Thank you for your valuable response.
Based on the machine number. Machine number
Oh,
should be unique. So
yes, yes.
linking it.
Yes, good. Thank you, Professor. Thank you for your valuable response. Yes, it is possible with the help of Internet Protocol version 6, simply called as IPv6. So as we all know, we have a two version in Internet Protocol. One is IPv4, next one is IPv6. So IPv4 supports up to 32 bits, whereas IPv6 supports 128 bits. Further, it will support mobility, security, and auto configuration. So nowadays, most of the foreign universities, foreign organizations, even in our not part of our Indians are also started to work with the Internet Protocol version 6. So with help of Internet Protocol version 6, we can assign the addresses to all the devices in the world. So one of the notable things here is in IoT, IPv6 is preferred rather than IPv4. So how the architecture of IoTs are formed? It's very simple with the help of 5 basic blocks. Start with IoT device, gateway, modem, followed with cloud and server. So IoT device. IoT device consists of sensors, actuators, controllers, etc. So the main role of the IoT device is used to sense the physical events. So some of the events are temperature, pressure, so once the data is, it will be forwarded to the gateway node. So here, the gateway is nothing but a wireless Wi-Fi. So they prefer a wireless medium. So with help of a wireless Wi-Fi, the data are forwarded and will be stored in the cloud environment with the help of modem. And finally, the server will take some appropriate action based upon the received data. So here, action means switch on the motor, switch off the motor. So these are the some actions performed by the user or maybe a supervisor. So these are the simple architecture of IoT. So we need a 5 basic things to connect the IoT environment. And while we're designing an IoT, what are the challenges we are facing? We're facing various challenges, but most important challenges are security, network challenges, and software development challenges. Security challenges. So as we all know, n number of physical devices are connected to the internet for sharing of data. So definitely here, huge volume of data are processed at the same time. All the data are stored in the cloud environment. So the hackers will easily attack our data. For example, you can take the bank transaction. It's one of the real-time example. You can consider the bank transactions. While we're transferring one amount from one account number to another account number, maybe the hackers will attack our account. Means it will be very easy to easily crack our accounts. So in order to avoid these kind of crises, the IoT provides some security algorithms. That security algorithms helps to detect unsecure devices as well as it blocks unwanted traffic. So they allow only useful informations. And next thing is network challenges. So the network challenges deals with scalability, diversity, and low power communication. The final thing is the software development challenges. As already mentioned here, huge volume of data are processed at the same time. So definitely big data analytics will play a key role in the IoT environment. So these are some major challenges in our IoT environment. So what are the platforms, IoT platforms? So the IoT platforms usually fulfill the gap between IoT device and IoT applications. So some of them are Amazon Web Service, Google Cloud Platform, and IBM Watson IoT platform. So these are the platforms which fulfill the gap between IoT device and applications. Last thing is the IoT advantages. So while using an IoT, what are the different kind of advantages we are facing? First thing is, with help of IoT, we can provide a good connectivity among the n number of devices. Moreover, it uses some intelligence algorithms to find out the faults which are occurred in the industrial side. With the help of IoT, we can save huge amount of energies, especially in the home automation applications, and provide some safety measures. And final thing is, with help of IoT, we can sense any kind of physical events. So as of now, I just give some basic definition and architecture of IoT. So simply, IoT means n number of physical devices are connected over the internet for sharing of data. Is everything is okay? Shall I continue? My voice, my slides is all visible and audible?
Sure.
Yes, sir.
Thank you.
Yes,
Thank you,
sir. Please go ahead.
Thank you. Thank you for your response. So next, we can imagine now we are going to design an IoT technology. So what are the enabling technologies available in our IoT? So while we designing an IoT, we need some other technologies to work along with the IoT environment. So these are the some enabling technologies, cloud computing, wireless sensor network, embedded system, edge device, sensors and communication protocols. Among these, the sensor will be a hard part of our IoT environment. So I just start with the hard part, sensors. So sensor is a device which is used to sense the real-time entities. As I already mentioned, some of the real-time entities are pressure, temperature, vibration, etc. Here the sensors usually takes the input as a physical quantity and it produces output in the form of electrical or in a mechanical format. So based upon the classes, sensor classes, they will further classified into two categories. One is based upon output and based upon data type. So based upon output, we have two types of sensors. One is analog sensor and another one is a digital sensor. So as we all know, the analog sensor means it produces a continuous output signal, whereas digital sensors produce discrete digital output. Discrete means, for example, logic 1, logic 0. Logic 1 means, you can imagine, switch on the motor. So these are the some actions. So switch on the motor, it will be denoted as a logic 1. Switch off the motor, it will be denoted as a logic 0. So likewise, we can use the digital sensors. Scalar sensors are based upon the data type, they will further classify it into scalar sensors and vector sensors. So one of the beauty here is the scalar sensors produce the output signal that is proportional to magnitude only. But in vector sensors, the output signal that is proportional to magnitude, direction as well as the orientation. So this is one big difference between the scalar sensors and the vector sensors. So these are the basic classes of sensors. So now we have a sensors for sensing purpose. So that is our first part of our enabling technologies. Okay. So in that first part, we just simply sense the physical events. Once the data is sensed, it will be stored in the cloud environment with help of edge device. So now, what is the meaning of edge device? Edge device is a device that provides entry point into the service provider network. So, as we all know, some of the examples of the edge devices are routers and switches. So, these two terms, routers and switches, are the most significant hardware components in the networking area. So the switches is used to connect the local area network, LAN, local area network, whereas the routers are used in connecting the wide area network. So embedded system. So embedded system in IoT consists of microcontroller, memory, organizing unit, and IO blocks. Microcontroller. So the microcontroller is used to processing or controlling our sensory data. Once the data is sensed, maybe or processed, it will be stored in some memory. Maybe it will be a RAM, a ROM, or cache memory. So here the data is sensed, processed, controlled, stored, and finally it will be communicated to the higher layers with the help of organizing units. Nothing but a communication units. So we prefer two things here. One is Ethernet and Wi-Fi connectors. Ethernet will be used for our wired connections, and whereas wireless we are used for our Wi-Fi connectors. So here, real-time operating systems are preferred rather than other operating systems in IoT. So communications. So these are the communication protocols. With the help of these communication protocols, we can achieve the communications in a good manner. RFID, Bluetooth, Zigbee, and WiMAX. One of the notable things here is Bluetooth and Zigbee more or less used in the same applications, same kind of scenarios, because both are used to connect wireless personal area network. Both support up to 10 meters, but only one difference is that Bluetooth is used in high power applications, whereas Zigbee is used in low power applications. So this is one of the main difference between the Bluetooth and Zigbee. So based upon your application, you can go with either Bluetooth or a Zigbee. So now we have a sensors for sensing purpose. We have a embedded system for processing or controlling our sensory data. We have a communication protocol for communication purpose. So now we can frame these three terms into one network. That network is called as wireless sensor network, simply called as WSN. So WSN is a collection of tiny sensors that are widely distributed around the geographical area to sense various physical events. So as I already know, some of the events are pressure, temperature, etc. So here is a simple architecture of our wireless sensor network. We have two main components. One is a sensor, next one is a sink. Sink, the main role of a sink is used to gather all the sensing information from the sensors. Sometimes the sink is called as gateway, sometimes called as a base station. So one of the real-time example of a wireless sensor network is how wireless sensor networks are used in forest fire detection. So initially, the sensor nodes are randomly deployed in the forest area. Once the fire event is occurred, it will be intimated to the sink node with help of intermediate nodes. So here sink will do some aggregation functions and it will be finally forwarded to the firefighting officers with the help of internet. So here, one of the major constraints of wireless sensor network is a battery limitation of sensor nodes. So we have to save our energy of the battery sensors. So most of the researchers introduce various concepts like clustering. So clustering is one of the preferred technology in order to save the energy consumption in our sensor nodes. So clustering, what is the meaning of clustering? Because the clustering concept will be applied in the various domains like image processing, sensor networks. So various fields we can implement the clustering approach for like video object detection, so like various applications. So clustering means very simple. The whole network is divided into multiple clusters. For each cluster, one node is selected as a cluster head. The remaining nodes are considered as a cluster members. The role of a cluster member is used to sense the events like fire event, and it will be forwarded to the corresponding cluster head. After that, the cluster head aggregate the data and it will be forwarded to the sink node with help of intermediate cluster heads. So by this way, the clustering approach reduce the energy consumption, because here they didn't prefer a direct communication. So here, with the help of a clustering approach, we can reduce the energy as much as possible. Finally, cloud computing. So cloud computing is also one of the thirst areas, because it is used to store or access our data over the internet instead of using our hard drives. So that is the beauty of our things. We can store our data all in the cloud environment. So we don't bother about that. We just simply place and simply store in the cloud environment. So with help of a cloud, we can access our file from the remote location. And moreover, it provides some on-demand service. On-demand means whenever we need, we can access. So these are some cloud service providers. Microsoft Office provides some clouds, Google Clouds, Amazon Web Service, iCloud. So these are some service providers which is used to provide some services like email service, storage and backup service. With the help of these cloud services, we can create as well as testing our applications. And finally, delivering softwares on demand basis. So these are some enabling technologies. That means with the help of these technologies, we can integrate various fields we can implement like this. So next, what the sensors are available? Because we have a variety of applications. So we need variety of sensors. So in which application we have used different kind of, what kind of sensors are used. So first of all, we learn what kind of sensors are available, how we can interface that sensors to our IoT as well as a blockchain environment. So my voice is okay? Everything is okay. Shall I continue?
Yes, sir. Your voice is
Thank you. Thank you. So I hope most of the theory related presentations feel very bored, but I just have to reduce some theory concept, and I hope I will continue within some open source tools, because it belongs to pure IoT environment. But our topic is related to blockchain. So I just some little bit intro about how IoTs are. We can frame the IoT environment with the help of open source tools in the last half an hour in the first sessions. So at that time, the sessions were very interesting because we are using some open source tool. Simultaneously, people also used in their laptops or desktops. So for that, we need some sensors. So what are the different type of sensors available in the market? So these are some sensors: ultrasonic sensor, gas sensor, color sensor, PIR sensors. So these are some different kind of sensors which are available in our market. So among these, I'll just give you some brief introduction about some most important sensors. Like I just start with some light sensors. So the light sensors used to detect the light. As we all know, will be used in the light pole on the street. It turns on automatically during the night times. Next sensor is a proximity sensor. So the proximity sensor is used to detect nearby objects. One of the real-time example is we can see in that shopping mall. While we enter near into the door will automatically open. So that is based upon the proximity sensors. Moreover, the proximity sensors also used in robotics. It is used to measure the distance from the robot to some other particular specific target objects. Even in our mobile phone also, we have some proximity sensors. So whenever you have a time, you can browse your configuration in your Google and you can check it. We have one proximity sensors. It is used to detect the nearby objects. And next, most important sensor, the last 1 year, during the COVID time, most of the researchers done their research related to temperature sensor. So as we all know, the temperature sensor is used to measure the temperatures. PIR sensor, passive infrared sensor. So it is also used in some real-time applications, like we can detect animal or human crossing in our borders. You can imagine, especially we are using in the forest area or maybe in the military areas. So we have one border, and that border some animals or humans are crossing often. So we have to identify the persons or identify the objects. Like, so at that time, we are using a PIR sensor. So just PIR sensor simply detects whenever the object is coming closer to the PIR sensor, it will just intimate to the higher officials. So with help of PIR sensors, we can detect the objects. Ultrasonic sensor. Yes, ultrasonic sensor is also used to measure the distance of the target object. So here we have two components, as we all know. One is a transmitter and a receiver. So transmitter is for transmitting the data, and receiver is used to getting the receiver. This is all we all knows in the previous years. And while we interfacing the sensors, we are facing some challenges. So what are the challenges? Because we all know about the theory concept of sensors, or we all know about we can easily buy the sensors, but how we can interface? That is the beauty of the IoT environment. Because I already mentioned, sensor is a hard part of our IoT. First you strong in the sensors, okay, then you have strong in the IoT environment. So how we can interface? Most of the sensors, you can take 70% of sensors are resistive sensor. So what is the meaning of resistive sensor? Resistive sensor means it produces the output in the form of resistance. For example, you can take a photoresistant, the LDR sensor. Whenever the light is falling on the LDR, the resistance of sensor is changing. But we are using maybe Arduino board as a microcontroller, okay? But the Arduino board will read the signal in the format of voltage. Once again, I repeat it. Our sensor produces output in the form of resistance, but Arduino board will read the signal in the format of voltage. So now we have to convert the resistance value into voltage with help of voltage divider rule. The most of the EC background and EEE background students or faculties are already discussed, have been studied in their first year or second year subjects. Voltage divider rule. It's very simple. We have to find out the output voltage with the help of the second resistor divided by sum of resistor into supply voltage. For example, we can assume like this. We have a two resistor, R1 and R2. Both value is 1K, nothing but 1 into 10 power 3 ohm. And our supply voltage is 3 volt. What will be our V0? Anyone from participants? What will be our V0? Participants? So what will be our V0? Yes, 1.5 voltage. Thank you. So thank you for your response. Yes, half of our supply voltage. Okay, so likewise, we have to convert our resistance value into voltage value. This is our first conversion. And second conversion is, these are the two conversions while we interfacing our sensors. The second conversion is the Arduino board takes the analog value in the format of 10 bit, nothing but 2 power 10. The range is 0 to 1023. But the users are maybe in the specific applications, we need a voltage value in the format of 0 to 5. So we have to convert 0 to 1023 into 0 to 5 format. That conversion formula is 5 divided by 1023 into A. Here, A is our reading value. For example, our reading value is 1023. So our conversion voltage is 5 volt. So likewise, we have to convert that reading value into our user understandable value. So these are the two conversions while we're focusing on interfacing the sensors. So I already mentioned, I just start with some intro about IoT because our session is how we can interface IoT and blockchain. So we need to know about these two technologies clearly. Then only we can think about integration part, because the integration part is a new era. Because IoT have some advantages as well as some drawbacks. At the same time, blockchain also have some advantages and also drawbacks. How we can interface? So I will discuss in the next session, maybe in the next session, following sessions. So for that, we need to know about some IoT basic things. So that's why I just start with the IoT, because most of the participants feel why the speakers just start with the IoT environment is not need to know about, not like that. We need to know about these two technology depthly, then only we have to understand the integration part. I just start with the blockchain and I just tell that while integrating, we face like a security problem. What is the meaning of security? Or reliability problem? Or integrate problem means that definitely some speakers are not, means some participants are clearly not know about the clear era. So that's why I just start with some intro about IoT. How we can frame the, for that next is IoT. It's very simple. I'm not focus upon each and every layer. I just simply will provide us a common language for IoT architecture and IoT systems. So any new technology you can take, they will introduce some reference models. So that reference model will provide us a clear overview of the new technology. So here, IoT have 7 layers like OSI layer in our computer networks. We have 7 layers. I think we all know. Start with the physical layer, nothing but sensor will be using the first part. So I just give you clearly I give you 3 layers, not in the 7 layers. I just give you some intro about the 3 layers only, because these 3 layers only used in the blockchain as well as various new technologies. First layer is the IoT layer. Here, the sensors, controllers, actuators are used in the IoT layer. Next thing is fog layer. Here, the unwanted sensory data will be avoided here with the help of some filtering mechanisms, with the help of some aggregation mechanisms. Here, the edge computing will play a key role in the fog layer. And third one is the cloud layer. Cloud layer means here the sensory data all stored in the cloud environment. So these are the 3 layers we have to remember while we designing an IoT with other technologies. First one is the IoT layer, and second one is the fog layer, and third one is the cloud layer. What are the applications of IoT? Because where the IoTs are used? Because you mentioned that IoT is an emerging technology, but where the IoTs are used? So the IoTs are used in so many real-time applications like healthcare, smart city, smart retail, smart industry, smart agriculture. So whenever the term smart comes, definitely the IoT will come. So these are the global distribution of IoT projects. So here the x-axis, they will be indicated different IoT applications used in the different countries. So from this, I have to say something. Because most of the researchers done their research related to various IoT areas, but still we need some solution for particular 3 areas. These are the 3 areas or current research areas in IoT. In case you are going to integrate blockchain with IoT, at that time these 3 areas, you can concentrate in these 3 areas, because these 3 areas are the predominant used area in our day-to-day life. One is smart healthcare. So I will give you in the next session how the IoTs and blockchains are integrated or how they will be used in the smart healthcare. The first area, kindly note down the 3 research areas. One is smart healthcare. And next thing is smart agriculture. But nowadays, in the foreign universities, they started to work with next level of smart agriculture called climate smart agriculture. It is also new era. So kindly note down that these two, one is a smart agriculture and climate smart agriculture. So whenever you have a time, you can go through what is the meaning of climate smart agriculture. Because we all know about the smart agriculture concept. Okay, and last thing is industrial automation. As we all know, the industry 4.0, fourth revolution. So these are the 3 areas is a future research direction. Okay, so you can think like this, how we can integrate IoT and blockchain, particularly in these 3 areas. Okay, one is smart healthcare, next thing is smart agriculture, and third thing is industrial automation. I just give some intro about how the IoTs are used in the agriculture environment. So you can collaborate IoT and blockchain with agriculture field. Because agriculture play a significant role in our day-to-day life. So we need some new technologies like IoT, blockchains, in order to improve the production side. So one of the possible approaches is greenhouse technology. Greenhouse technology provide a way to control the environmental parameters in order to improve the production side. So this is a working structure of IoT systems. So how the IoT systems are used. So you can imagine we have 3 parts. One is input part, communication part, and third part is output block. So in the input part, we can simply install our IoT applications in our mobile phones. Once you open, you can have 2 options. One is on off. Once you click on button, the motors will on. Once you click the off button, the motors will be off. One of the notable thing is these 2 operations will be performed remotely. That means we just simply sit in our home. We can control our agriculture fields. So likewise, we can use the IoT environment. But one of the notable thing is here, all the IoT data are stored in the cloud environment. So here we can use the blockchain technologies. So we can secure our data which are stored in the cloud environment with help of blockchain technology. So that will be a future direction of our current research areas. So how the IoTs are used in industry 4.0? It's very simple. I just simply skip all these things just because we already know about IoT in the depth. We have a 4 revolution in industry. I will just give you an intro about the industrial point of view. So we have a 4 revolutions. One is industry 1.0. That means you just start with some steam concept. Next revolution, they will concentrate about some electricity concept. And the third revolution, they provide some automations with the help of computers, robots, etc. And final, our current revolution is a 4th revolution. So here, the normal factory is converted into smart factory with help of our IoT, blockchain, and cybersecurity technologies. So one of the big difference between the industry 3.0 and industry 4.0 is, in the industry 3.0, they only provide some automation. But here, in addition to the automation, it provides some flexibility and quality. So these are the some enabling technologies in industry point of view. Kindly note down these are the some research areas or you can concentrate in the industry point of view. For example, you can work with IoT in industry 4.0 or you can work with cybersecurity in IoT or in industry 4.0 or you can concentrate on cloud computing. So these are the some technological pillars of industry 4.0. So this is one of the global view of how the IoTs are used in the Industry 4.0. You can imagine we can simply install our IoT applications in the smartphones, or maybe that this is our dashboard. So with the help of these dashboards, we can monitor that supervisor or higher officials can monitor the statistics of each and every equipments in the industrial site. All these monitoring operations will be performed remotely with help of our IoT. So one of the notable or one of the most important thing here is the IoT will give us a real-time updates. So all the actions are based upon the real-time data, not on the predefined data. That is an additional feature in our IoT. I already mentioned, it provides quality as well as the flexibility in the manufacturing process. Hierarchy, we need 4 hierarchies. While we concentrating on the industrial sector, we have to focus on these 4 hierarchies. First hierarchy is the field level. Field level means the sensors, actuators are used in the field level. And next thing is control level. Control level means some computers or some robots are used to perform some controlling operations. And third thing is a supervising layer, and final layer is an information level. So the third layer is used like interfacing concept, how the human and machine interfacing are acting here. And last thing is information level. It provides some production planning, customer and market analysis, and orders and sales, etc. So these are the some hierarchy levels available in our industry sector. How the IoTs are used in industrial robotics with the help of robotics as well as IoT as well as blockchain. How we can improve our industrial sector. So as we all know, the IoT uses some smart sensors as well as actuators to enhance the manufacturing process. So this is one of the working view of robots in our industry sector. So you can imagine, I will tell you some working method in the industry side. As we all know, the industrial equipment size is very huge. Once the fault is occurred, it is very difficult to find out the faults by humans. At that time, they introduce the robots in the industry sector. The robots simply find out the faults which are occurred in the industry equipments, and it will be intimate to the supervisors. In case the supervisor or managers are not available in the factory. So you can imagine like this. The managers or supervisor, maybe they will available in their homes, but we can control from the home itself with the help of our IoT technology. So through IoT, the managers or a supervisor just give the instruction to the robots to take some appropriate actions. So the robots will take some appropriate action like fault recovery. So through IoT, we can give the instructions. But one of the challenges here is all the data will be stored in the cloud environment now. That instructions will be further through the cloud environment or internet environment. The hackers will easily attack our data. So we need a blockchain technology. So in that cases, we need a blockchain technology. So the blockchain is used to secure the IoT data. So we need 3 technologies here. One is blockchain and IoT and robotic technologies. So you can collaborate these technologies and provide us a good solution in the industrial automation side. Why we need a robots? It's very simple. The robots will provide us very successful in the several industries because of their high level of accuracy, precision, and speed. So in the initial days, the human operators are preferred for performing these 3 operations. In addition to these 3 operations, precision, accuracy, speed will be provided with help of our robots. So that's why we need robots in our industry sector. Working scheme is very simple. Robot can sense the data. With the help of edge computing, we can perform only useful data. We can use the only useful informations. The unwanted data are filtering here with help of edge computing mechanism. So based upon the output of the edge computing, the robots will take some appropriate action. As already mentioned, the robots will take the action based upon the real-time data, not on the predefined data. So that real-time data will be provided with help of our IoT. So these are the some features. We can use multiple robots to analyze or to watch the statistics of each machines. As already mentioned, with the help of IoT, we provide some real-time informations. And final, most important slide here is, here we are going to use 4 technologies. You can imagine these 4 are thirst areas, nothing but emerging technology. How we can collaborate these 4? For example, I just start with the AI, artificial intelligence. You can browse it. Most of the faculty members conduct their FDP or STTP related to artificial intelligence. Why? Because these are the current research areas. With the help of artificial intelligence, we can detect the problems which are occurred in the industrial sector. Once the problem is detected, it will be intimated to the higher layers or higher supervisors with the help of communication protocols or communication networks. Here, 5G network is acted as a communication network rather than 4G. Okay, so next, the data are processed, or will be the supervisor will take some appropriate action through the internet. So here the IoTs are preferred, third technology, and fourth, all the data are stored in the secure manner with help of blockchain. So here, 4 technologies are used. This is a current research area. You can do these 4 technologies in the collaboration manner, especially used in the industrial side. Your research will be reach in the good position. Okay, don't do the previous things as clustering or energy consumption or maybe fault detection. These are the old techniques. You can think like the collaboration part. So here, how the IoT, how the 5G network, how the artificial intelligence, and how the blockchains are collaborated to work to provide the solutions, that is optimal solutions for industrial sector. Because in the industrial sector, we are facing so many problems in day by day. Because the machinery size is very huge. Okay, so we have to use these 4 technologies and find out the suitable solution is a current research area, that is the future current research topics. So whenever I have a time, I will just discuss some current research area. While we, in the teaching profession, we need to do the unique research, not the old research. Okay, we just simply browse, or we just simply take on base paper and we can simply modify, not only good research. So I published 5 free journals. That means 5 SCI free journals in the last 1 year. All are indexed in SCI and also Scopus are very good, repeated. All are free journals. I didn't spend single rupee. Only one thing is I have a unique research problem identification, and as well as I provide unique solutions to that problems. So I can collaborate wireless sensor network with IoT, fault directions. Now I concentrate medical image processing with IoT. Maybe in future, I can think about blockchain, IoT, and medical field. How we can collaborate these 3. So you can do the unique research. Definitely your paper, your research content will be selected in reputed SCI journals. That means free journals. So don't focus upon paid journals. It's not a good work thing or good research things. It's my kind request, because all are our faculty members. So all we are working in the very critical situations. So we need to save our money as well as we need to develop our innovative skills like collaboration part. That means integration part. Okay, so that is my kind request here. So the next thing is So anyhow, thanks for this response in the message. So now I'm going to introduce one of the open source tool called as the Tinkercad while I focus on IoT, because you can imagine IoT. First, we know, or first we have an IoT environment now. At that time only we have to interface the blockchain. So at that case, now I just give you some introduction about the Tinkercad. It is one of the open source tool. Okay, so those who are using the laptop, no problem. You can simultaneously work with me. The other people, don't bother about that. Simply note down the procedure steps. Whenever you have a time, you can work in the Tinkercad. So Tinkercad is purely for IoT environment, not a blockchain. While I am telling that Tinkercad tool means, first you have to design the IoT. Then you have to collaborate blockchain with IoT. Okay, so first I just start with the basic concept. That means LED blinking, automatic LED, and maybe whenever, suppose I have a time, I will discuss about the sensor interface. And definitely the next session, that means 12 to 1:30, I fully focus upon blockchain. So you can see my slides. Yes. These are my blockchain concept. Okay, so I have nearly 70 slides in the last session, because the integration part is a very important thing. Okay, so we needed two technologies, no problem on that. So don't bother about that. Why you concentrate on IoT? So thank to the event coordinator, because he give us such a wonderful 2 sessions. Because 1 session means definitely I will concentrate on the blockchain and IoT, but I have 2 session means I just give a relaxation time. Okay, so I will give you some open source tool. You can work in the IoT environment. Once you complete and once you throw it in that real-time part, real-time implementation part, then you concentrate the blockchain, because it is a different area. Okay, while we transferring our IoT data, that is a notable thing here. Data. The data will be stored in the cloud. It will be stored in the secured manner with help of our blockchain. Okay, so first I just give you how to frame or how to establish the IoT environment in the real-time applications. Shall I give the intro about Tinkercad? Otherwise, I will enter into blockchain. So what about the participants' opinion?
Please go ahead. Please go ahead and give an intro, because some of us may not be aware of this.
Yes,
We are not
yes.
from pure engineering background.
Yes, yes. So that is my session. My session is fully covers all the participants, not only for a CSE or not only for the because IT peoples. Because the CSE and IT departments are pure based upon these all the IoT are very very know about area. But my session is always concentrate on the all the because I belongs to EC, but my research belongs to IoT and blockchain. So no problem. So I will give some intro about the Tinkercad tool. It's very interesting tool because it is an open source tool. It's not a paid software. Okay. So first thing, before enter into the open source tool, in that open source tool, they preferred Arduino board. It's acted like a microcontroller. As already mentioned, microcontroller means it is used to processing or controlling the sensitive data. Okay, so we need to interface the sensors. The sensor is used to sense the data. That data will be processed with the of our Arduino board. Okay, so here, in case our sensor is based upon analog, that means we are giving the analog input. We prefer analog input. We have 6 options, A0 to A5. Okay, so you can use any one pin. And in case our sensor is purely based upon digital sensors. Okay, so in that sensor we have 14 pins. And power supplies, we have 2 power supplies. One is a 5 volt and 3.3 volt. So based upon the application, you can connect in either in the 5 volt or 3.3 volt and ground supply. So kindly note down the procedural steps in the Tinkercad. First step. Shall I start? Participant is not. not a pure theory concept. Okay, so just you can collab, we can integrate means we can interact means will be very interesting. The session is very interesting because the open source tool is very easy tool. Okay, so first you can type the Tinkercad in Google, Tinkercad, Tinkercad, and then enter. You will get various links. So in that you click first link, then click join now. So in that option, you will get some web page like this. Click join now. Then click join now. Once you will get sign in option. So sign in, you just click sign in. So click sign in. You can use your Gmail account, any of your Google account, give your user ID and password. So sign in with Google. And finally, you will get Tinkercad web page. So those who are using laptop, simultaneously work with me. Otherwise, no problem. You kindly note down these procedure steps. So wait, I will enter into my Tinkercad. So whenever we started to learn about the theory concept, it's very boring. I know the mindset of faculty members. You just always work with the open source tool. It will be very interesting. It will be easy to learn the so many components or so many devices in real times. I will show you some. These are my previous experiments. So many real-time projects, mini project, and applications related projects. Okay, so in that click circuits. So with the help of Tinkercad, we can design 3D environment also. But I will concentrate on circuit and connection only. So circuits, create new circuit. Create new circuit. So once again, I wish to tell that Tinkercad is only for IoT environment. Okay. So I will give you some intro about how we can design the IoT environment. Then in future, suppose if I have any session, I will give you some how we can collaborate the blockchain, that real-time scenario in that open source. Okay. Okay, so this is our workspace. This is a basic components available in our Tinkercad: a resistor, LED, different kind of sensors, multimeters, etc. So we have 4 options. One is code, start simulation, export, and share. With the help of these options, we can share our experiments to our designs to our colleagues and students. Okay, so first I start with the basic experiment, LED blinking. So for that we need a 2 component. One is LED. I just simply drag and place it. Next one is 9-volt battery. Okay. So you people able to view my screen, Tinkercad screen?
Yes, sir. Visible, sir.
Thank you. So once again, I repeat it. We need 2 basic components. One is LED and next one is 9-volt battery. So anyone from participant side, can you answer for this question? Because we have 2 terminal in LED. One is anode, next one is cathode. Which one is positive terminal? Anode or a cathode? Which one is positive terminal?
Anode.
Anode, good. Thank you, ma'am. Thank you, professor. Anode is a positive terminal. So now I'm going to tell you the connection procedure. The positive terminal of 9-volt battery is connected to anode of LED. So I can change the color. For example, I prefer red color for indicating positive. So this is an additional feature available in our Tinkercad. So we can use different colors for indicating different current flow. Okay, so next, the negative terminal of 9-volt battery is connected to cathode of LED. So I just give black color for indicating the negative terminal. So this is a simple connection. Okay, so once you finish all the connection procedure, you just click start simulation. You people able to see the output. You can zoom like this. Okay, you people able to see the output. LED is blinking. Okay, but one alert message is there. Current through LED is 915 milliamps, but it supports up to only 20 milliamps. There will be a huge difference. Okay, practically we can connect like this, means definitely the LED will burst. So this is one of the advantage while using a open source tool. So we can simply use the trial and error method. We can connect like this, we can different option, but in the practical, we can connect to the short circuit and maybe LED will burst. Okay, so in order to avoid the burst condition, we need an additional component. So that component is called as a resistor. So we just simply place the resistor here. Now I will modify the connection. So the positive terminal of 9-volt battery is connected to one end of resistor. The another end of the resistor is connected to anode part. We can give red color. The rest of the thing are same. Okay, so now click start simulation. You people able to see the output. LED is blinking without any alert message. Okay, so now what is the meaning of resistor? Because we have already studied in the circuit analysis or circuit theory concepts. Okay, the students are know about the theory concept, but practically where the resistor is used. You can do like this. We can show you the students here the practical applications of resistor. The resistor is used to restrict the current flow. Okay, so this is how we can use our Tinkercad and to show off so many devices in the real-time manner. Because we all studied in the theory concept only. We don't bother about, we don't know about the practical implementations. Okay, so likewise, the resistors is used to avoid the burst condition of LED. So this is our first experiment. Is it easy or is it very boring? Okay. Thank you for your valuable response in the chat box. Thank you, professors. Thank you, participants. Okay, finally, we completed our first experiments. Once we completed, it will be saved with the help of this option. Just you click and you can give any user preferred name, LED2. I give LED2, you can give LED or LED2 or 3, whatever may be. So we just simply click LED2. So all the changes are saved in the LED2. So one of the interesting thing here is all the files are saved in the cloud environment, not in our hard drives. Okay, this is a real-time example of cloud computing. Where the cloud is used, here you can show. This is one of the real-time example of cloud computing. Hard drives are not in our computers. Okay, this is one of the real-time example of our cloud environment. Okay, so next thing, second experiment, automatic LED on-off. This principle will be used in so many real-time applications. You can imagine in our marriage functions or any functions, the LED is on-off, on-off, on-off. That concept will be used in so many real-time applications. Automatic LED on-off. Shall I continue this Tinkercad for another 5 minutes? Or once I start with the theory concept?
No, sir. Please continue, sir.
Thank you, ma'am. Okay, so second experiment, LED, that means automatic LED on-off. Okay, here we need a 5 basic component. Kindly note on it. One is 9-volt battery. Next thing is very important thing here, relay switch, relay SPDT. You can browse in this basic component, relay SPDT. Third thing is Arduino board. Whenever the automation comes, definitely Arduino board will come. Okay, because here automatic LED on off. So automation. So definitely Arduino board will come. Okay. So and fourth and fifth thing is LED and resistor. The LED is used to avoid the burst condition of LED. Okay. So the resistor is used to avoid the burst condition of LED. Okay. So I will tell you the connection procedure. The first thing, I start from this positive terminal. So the 9-volt, the positive terminal of 9-volt battery is connected to terminal 12 in relay switch. Then the terminal 8 is connected in the ground part. Same way, the terminal 5, the terminal 5 is connected to in the digital pins. Why it will be connected to the digital means, kindly note on it. Here LED on off. LED on means logic 1. LED off means logic 0. So we need two things. That means 1, 0. So definitely it will be a digital concept. So we will give any one of the digital pins. So that's why I just given in this digital pin, not in the analog side. Okay, so I prefer 11 pin. You can connect in any pin, no problem on that. And finally, the terminal 6 is connected into the one end of a resistor, and another end of the resistor is connected in the anode part. And last, the cathode part is connected to the negative terminal. So this is a simple connection procedure. Okay. So the most of the faculty members are crossing this scenario. You just instruct our students to do the projects, but most of the students in our side are maybe from the south part of our students are not doing the projects. Why? You can ask the questions. They simply told, sir, project covers some programming concept. It's very tough to learn the C program, C++, Java, or Python. Okay, so you can go and you can tell the Tinkercad tool that kind of students, because the Tinkercad use block concept rather than code concept. It's very interesting here, because we don't bother about the coding. We just simply place the block. Tinkercad will convert that block into coding. I just simply show you of the real-time samples. You just click code. Okay, so you just delete previous predefined codes with the help of this delete option. Okay, so we have 3 options. One is block, next one is block plus text. Text means coding. Okay, next one is text, simply coding. So I prefer block concept, because we are from maybe not related to CSE or not related to IT. So we just use the block concept. So here we have 6 blocks. First block is output. So here some output blocks are available. For example, print to serial monitor. That means in that serial monitor, we can print our output. Okay, like a monitor, and play speaker on and set particular pin to high or set particular pin to low. So likewise, these are the some output functions available in the output block. Next one is input block. So like we are going to read the digital. That means read digital. We are going to read analog. That case we have used the read analog. So likewise, these are the some reading operations will be performed. For example, we are going to read the temperature sensor. Okay, because we are using the temperature sensor in the real-time application. So at that case, we have used the read temperature sensor. So these are the some input blocks. And control means some waiting operations like if block, if else, repeat block, wait instructions. These are some conditional loops are available in the control block. And math means some operators, mapping operations also available. Mapping means we are just simply map our one particular value into another particular value. You can imagine, I already mentioned in that sensor interface, I'm going to convert 0 to 1023 format into 0 to 5 format. So that kind of cases we use the mapping concept. Okay. So I don't have any time. That's why I just simply tell this concept. Okay. So these are the some basic blocks. So back to our second experiment. In the second experiment, we need a on the LED and wait for 1 second and off the LED and wait for another more second. Okay. For that, I use set particular pin to high. For example, I connected in the 11th pin. So I just use 11th pin to high. This is our first case. And next case, I have to wait for 1 second. We can change 2 seconds, 3 seconds, no problem at all. And next thing is, again, I have to switch off the LED. That means use low case. First one is a high case and next one is a low case. And last thing is you have to wait for another more second. Kindly note down it. I simply place the blocks. Okay. Once this is a simple block concept. Okay, just start simulation. You will get an output. Yes. You people able to see the output? LED on, off. I didn't press any key. It just simply on, off, on, off. Okay, you people able to see the output?
Yes,
Okay.
yes.
Thank you. So now you can check it. I just simply place the block. But Tinkercad will convert that block into text. That means codes. I didn't do anything. These are the some coding concept. Okay. So we don't bother about this coding concept. We just simply place the block. Okay. The Tinkercad will automatically convert that block into code. You just instruct your students. Students don't bother about that coding concept. We use Tinkercad because in that Tinkercad they introduced the block concept. It's very interesting. Most of the north side, most of the foreign universities started to work with the Tinkercad. Already 1 or 2 years they have started. Okay, so it'll be a very interesting tool. With the help of Tinkercad, we can design various projects or various real-time concepts in related to IoT. Okay, next thing, I just give intro about IoT. You can imagine how the blockchain are integrated with this kind of scenarios. Okay, so I hope I don't have much time. That's why I just conclude this Tinkercad tool. You can see I have a various real-time project as well as various sensor interface concept. Okay, I just simply show you of this. So these are my previous experiment. We can integrate potentiometer sensors, LDR sensors, temperature sensors. So likewise, the Tinkercad will help us to implement so many real-time projects. So whenever you have a time, kindly go through and kindly work in the Tinkercad. It's very interesting tool. Once you started to learn this kind of open source tool, definitely our innovative skill will be increasing. Okay, once you're finishing off our that IoT experiments, then you started to work with the blockchain concept. Because here the data are stored, our data are processed. Okay, so now I will conclude this sessions with the end of some drawbacks of IoT. Okay, so we have so many advantages in IoT. So we can sense, we can provide connectivity, we can have artificial intelligence algorithms to find out the problems. But still, there will be some drawbacks. One of the major drawbacks is the data privacy and security of our data. Okay, so we have to secure our data. Okay, so you can think like this. We have to secure our data. For that, we need a new technology for securing the IoT related data. So for that, we need a blockchain. So the blockchain will help us to secure the IoT data, because what kind of problems will be arise? didn't use the security algorithms. I will tell you in the next session. Various problems are occurred. So in that case, we need a security algorithms like blockchain technologies. So in the next session, 12 to 1:30, definitely I will concentrate on the blockchain technology. I just give some intro about blockchain technology. What are the meaning of public blockchain, private blockchain, hybrid blockchain, and how we can collaborate the IoT with blockchain. And I will give you 3 applications, okay, where the blockchain and the IoT integration part is used. And I will give you 4 challenges while we integrating the IoT and blockchain. So the next session, I hope it will be especially useful for CSE and IT faculties. The first session, I hope the useful for other departments like ECE, EEE, and maybe other departments. So thank you for the patience and thank you for the listening my sessions. Okay, so next session we will soon connect in the 12 o'clock. Just take some refreshment and I look back in that 12 o'clock. We will concentrate on blockchain and how we can integrate the IoT with blockchain. What are the challenges? What are the opportunities? What are the applications are used in this? So thank you, participants.
Thank you, Prashant.
Thank you. Thank you, sir.
Participants, do you have any other queries? Because the session was continuously interactive. So is there any other questions you want to ask Prashant? You can have a look.
Thank you, participants.
So I have posted the session 1 feedback. Kindly fill the form. It will be open up to 12 o'clock. So once session 2 started, the feedback link for session 1 will be deactivated. Right? Thank you so much. We'll meet at 12 o'clock. Thank you. Prashant, have a break and we'll assemble at 12 o'clock.
Sure, sir. Sure, sir. So thank you, participants. Thank you. Thank you for your valuable message in the chat box. Thank you. Thank you. We will meet soon in the next session. Thank you all.